Let's take a look at number 35. This is adding or subtracting rational expressions with different denominators. So adding, that's weird. I should have put adding or subtracting on that previous problem, but oh well. Adding, subtracting rational expressions with different denominators. Okay, step one. We're going to factor all the denominators. Step two, figure out the LCD and rewrite each fraction with that new denominator. Step three, add or subtract the top parts, put into a single fraction. Step four, factor the top, factor the bottom, and 5, cancel if necessary. So let's take a look at this particular problem. If I can find it, there it is, 35. Now this one's pretty simple. We won't have to do very many of those steps, I don't think. 2, well, maybe, plus 5 over x minus 9. Step 1, factor all your denominators. Well, can't do anything with these. These are pretty basic. Step 2, figure out the least common denominator and rewrite each fraction with that new denominator. So this is step 2. Now to figure out our least common denominator, we take a look at each factor. Like I'll start with the x plus 9. And we're looking for the greatest number of x plus 9s in any single denominator. There's 1 here, none here, so the greatest number of x plus 9s in a single denominator is 1. And then I go to my next factor, the x minus 9. And I'm looking for the greatest number of x minus 9s in any single denominator. There's none here, 1 here. So the greatest number of x minus 9s in any single denominator is 1. So that would be our least common denominator, the LCD. And we're going to rewrite each fraction with that new denominator. Now you have to look at the new item that's put down below. Here we have x plus 9. The x plus 9 is still there. The new part down below is the x minus 9. So we have to put that up on top also. So whatever you put down below, you have to put up on top. The mathematical rule on it is whatever you multiply by the bottom, you have to multiply by the top. And our other one here, we had an x minus 9. Well, that's still there. The new item down below is the x plus 9. So we have to put an x plus 9 here. Again, whatever you put down here, you have to put up there. Well, 2 times x is 2x, and 2 times negative 9 is negative 18. You do not ever want to get rid of the parentheses down below. You're actually hoping something will cancel at the end. And here, 5 times x is 5x, 5 times 9 is 45. Okay, what step are we on? Step 3. Add or subtract the top parts and put into a single fraction. Well, I'm going to have 2x minus 18 plus 5x plus 45 over x plus 9, x minus 9. Now, no matter where you are in mathematics, what section, what course, if you can combine together like terms, combine together the numbers, usually you do. So 2x plus 5x is 7x, and negative 18 plus 45 gives us 27. Yeah, I believe so, 27. And then this remains. Step 4, factor the top, factor the bottom. Bottom's already factored, and it should be if you didn't actually multiply these together. Top part I can't factor anything out. It looks like GCF, but 27 is not divisible by 7. So obviously we cannot cancel because these don't look alike. So 7x plus 27, and they go ahead and multiply those through. So it'd be D. They multiply these. X times x is x squared. X times negative 9 is negative 9x. 9 times x is 9x. And 9 times negative 9 is 81, or negative 81. Now you'll notice the negative 9x plus 9x cancels away, and we get D for our answer. Now these are actually conjugates of each other. Conjugate means the first and second part are the same. See how this is x and 9 and this is x and 9? But the sign in the middle is different. This is positive and this is negative. If you recognize they're conjugates of each other, conjugates are easy. All you have to do is multiply the first parts together. X times x is x squared, and 9 times negative 9 is negative 81. Now if you don't see it, no big deal. You'll notice they'll cancel away just like we saw here. So 35D. 35D, and it checks. So that'd be our answer.